Hi, welcome to a quantitative aptitude video on boats and streams from careerright.com. Placement test, job interviews and all other exams generally have 1 to 2 sums from this topic. Boats and streams is very easy to understand and solve, just like the speed, distance and time sums. So in this video, we are going to see tips and tricks to easily and very quickly solve these sums. To practice questions on aptitude, you can go to careerright.com, which has practice test as well as 1000+ aptitude questions. So let's begin. If you know speed, distance and time, these concepts, then you can understand boats and streams in just 1 minute. So if you do not know speed, distance, time, then I would suggest that take a look at the video which we developed on speed, distance, time. Here also I am going to explain the concept of speed, distance, time or the formulas related to speed, distance, time in very short, in a minute. Okay, so first let's revise speed, distance, time. Now speed, distance and time have their own formulas. Those 3 formulas, let's see how to remember them. First, draw a Y. Okay, now out of speed, distance and time, generally the quantities or the amount of distance given is more, like 1000 kilometers, 2000 kilometers or 500, 600 kilometers. Time is generally in seconds, minutes, hours or what we say 1 hour, 2 hour, 10 hours, like that. Speed is also 150 kilometers per hour, 200, maximum that much. So distance quantity is more, right? So write distance over here. Now speed and time can be written anywhere. You can write speed here, you can write time over here. Even this is fine. This is distance, time over here and speed over here. Let's go with this. Okay, the formulas for distance, speed and time can be given as distance is nothing but speed multiplied by time. Time is nothing but distance divided by speed. This is the distance divided by speed. So same way speed would be distance divided by time. See how easily a small y, dSty, okay, this y, this dSt helps you remember all the 3 formulas very accurately in exam. So whenever you go to exam, just write this somewhere in the corner so you will remember the formulas. Now speed, distance, time, there are generally 4 types of sums asked. The first one is distance is same. The second type is speed is same. The third type is time is same. And there is a 4th type where we have to find the average speed. Now, do we know what is the formula for speed? Yes, it is distance upon time. Then what is average speed? It is nothing but total distance upon total time, right? We'll see how to calculate this. You can check out the speed, distance, time video also to see more examples of average speed. But over here also, if there is a sum related to average speed, we'll see how to calculate total distance and total time and get the average speed. Now, with this revision of speed, distance, time, let us move on to boats and streams. Now, in boats and streams, there is nothing but speed, distance, time only. You have to solve the sums same way as you solved the speed, distance, time sums. There is only one small addition, that is you have to consider the speed of the river and the speed of the boat, right? And the speed of the boat. So over here we do not have normal speed, right? Normal speed is not there. What do we have? We have the speed of the river and we have the speed of the boat. Let us see what we exactly mean by this. Now, in speed, distance, time, for example, this is a river, right? It is flowing in this direction. There is a boat in this river. Now, this boat is also moving in the same direction. Let the boat be moving at the speed x kilometers per hour. Let the river be moving at the speed y kilometers per hour. Since both are moving in the same direction, this is known as downstream. Okay, this is known as downstream. Now, what should be the speed when we are talking about downstream? So, what would be the downstream speed? It would simply be x plus y. Now, why x plus y? Because we know whenever we are swimming in a river, if we flow in the direction of the river, the speed increases, right? We go very fast. That is the reason we add it. So downstream speed is x plus y. Now let us assume it is the same river and it is moving in this direction, and there is a boat, okay, which is moving in opposite direction, right? Speed of the boat is x, speed of the river is y. This, since the boat is moving in opposite direction, it is called as upstream. Exactly opposite. Opposite of down is up. So downstream, upstream. Now, what is the upstream speed? Upstream speed is nothing but x minus y. Here we had plus y, here we had minus y. Now why minus? We know when we are swimming in a river and when we swim in the opposite direction of the river, we will go very, very slow. Okay? Since we are going slow, we subtract, right? The speed is actually decreasing. That is the reason for upstream speed to be x minus y. So whenever you are solving boats and streams sums, you just have to remember two things. What is this? Let's see over here in the corner. One is dst and other is x plus y, x minus y. These two things are useful to solve all the sums related to boats and streams. Let us see how. Question number 1. What will be the boat's speed in still water and the speed of river if the boat takes 12 hours to row 48 kilometers upstream and 8 hours to row the same distance downstream? So now we have boats and streams sum, so we'll have our dst and we'll also have x plus y and x minus y. Okay, so now what is y? Y is nothing but speed of river, right? And what is x? X is nothing but the speed of boat, right? These are speeds. Now speed of boat or speed of man, whatever it is there, it is generally given in still water. So x is nothing but speed of boat in still water. Okay, so it is not the speed of boat in running water. We never consider the speed of boat in running water. We generally consider speed of boat in still water. So x is speed of boat in still water, y is speed of river. What is x plus y? X plus y is nothing but downstream speed, correct? What is x minus y? It is nothing but upstream speed, right? Since we know this, let's start solving the sum. What they have given, what we have to find? Boat speed in still water and speed of river. That means we have to find speed. What is speed? Distance upon time. From where do we get that? We get from our dst, from over here. Speed is distance divided by time. Speed is nothing but distance upon time. They have given two scenarios. One is upstream and other is downstream. So let us consider both the scenarios. Now in upstream scenario, what have they given? They have given that the boat takes 12 hours to row 48 kilometers upstream. What is the upstream speed over here? It is nothing but upstream distance upon upstream time. What is the upstream distance? 48 kilometers they have given. Time taken is 12 hours. That would be 4 kilometers per hour, right? And what is upstream speed? We know it is x minus y. So therefore what do we get? X minus y equal to 4. This is our first equation. Now let's consider downstream case. Downstream speed is s, that is nothing but ds. So distance traveled is same distance downstream, right? So we have 48 kilometers, time taken is 8 hours they have given. So that would be 6 kilometers per hour. What is the downstream speed? X plus y, right? So we have x plus y equal to 6. This becomes our second equation. Now we have to find value of x as well as y. So let's add these equations. What do we get? X minus y plus x plus y equal to 4 plus 6. So this gets cancelled to x equal to 10, x equal to 5 kilometers per hour. What is x? X is the speed of boat in still water. Now let us find out y. Put the value of x in any equation, this or this. Let us put in equation number 1. What do we get? X minus y equal to 4. 5 minus y equal to 4. Y equal to 5 minus 4. 1 kilometer per hour. This is the speed of river. See how easily using dst and just x plus y and x minus y we were able to find the answer. Going to question number 2. Simran takes twice as long to swim up as to swim down the river and has the speed of 12 kilometers per hour in still water. What is the river's speed? Again, speed, distance, time sum and boats and streams. So we have x plus y as downstream and x minus y as upstream. We have to find the value of y. We do not know y, but we know value of x as 12 kilometers per hour. Also, what have they given? Simran takes twice as long to swim up as swim down. So time, okay, while going upstream is twice the time going downstream. So tu is time going upstream, td is, let td be the time going downstream. What is the formula for time? Time is nothing but distance upon speed. So upstream distance upon upstream speed, right, is equal to 2 into downstream distance upon downstream speed. Correct? Now, what is the distance upstream? Have they given? No. Let us assume that Simran travels, say, d kilometers, right? So let us assume the distance traveled upstream is d kilometers. What is the upstream speed? SU, that is nothing but this US. Upstream speed is x minus y, we know that. So we'll write x minus y, that is 2 into downstream distance. Now here they have not mentioned how much distance does Simran travel downstream. So we should always consider in such cases that the upstream distance traveled is same as the downstream distance traveled. So here also distance traveled is d. What is the downstream speed? SD, that is nothing but this ds, that is nothing but x plus y. So we'll write x plus y. So this dd gets cancelled. What do we get? X plus y equal to 2x minus 2y. Correct? So what do we get over here? So this 3y equal to 2x minus x is nothing but x, but value of x is nothing but 12, that we know. So let's solve. What do we get? 3y equal to 12, y equal to 4 kilometers per hour. Speed of river is 4 kilometers per hour. See how easily we got the answer. Moving to question number 3. It takes P 1 hour to row to a place and come back. If the river is running at 2.4 km per hour and P has a speed of 12 km per hour in still water, what distance is the place from P's starting point? Now we have DST, since it is the speed distance time sum. Okay, we have our DST, and since it is boats and streams, we have x plus y as downstream speed, x minus y as upstream speed. X, value of x we know it is 12, value of y is 2.4 km per hour. So x plus y would be 14.4 and x minus y would be 9.6, right? So with this, let's start solving the sum. What they have given, P takes 1 hour to row to a place and come back. That means P is over here. P rows to a place. P goes to a place, okay, and comes back. So we can consider any direction as upstream and any direction as downstream. So let us assume that this is nothing but upstream. So this would be downstream, the opposite. Correct? You can consider this as upstream and this as downstream also. Vice versa is also correct. You will get the same answer. Now let us consider this as up and this is down. Do we know the distance between the place and P's starting point and the place? No. So let us, that is what we have to find out. So let us assume the distance be d kilometers, right? So P goes to the place and comes back. What I have given, in 1 hour P goes to the place and comes back. That means to row or to go upstream, the time taken is, let the time taken be TU, plus to come back again, that is come downstream, the time taken is TD, let the time taken be TD, is nothing but equal to 1. That means in 1 hour P goes upstream in some time plus P comes back downstream, okay, in some time. So both the times are nothing but the summation of both times is 1 hour. In 1 hour P goes upstream and downstream. So what is the formula for time? Time is nothing but distance upon speed. Correct? So distance is over here d kilometers upstream. Speed for upstream is x minus y, plus distance downstream is d. Speed for downstream is x plus y, that is nothing but 1. We know value of x minus y 9.6. D x plus y is 14.4. Y, from here we found those out. Correct? So D, what is the LCM over here? It would be 9.6 into 14.4. This would be 14.4 D plus 9.6 D equal to 1. Let's solve it over here. What do we get? 24 D would be equal to 9.6 into 14.4. 6 4s are, 6 1s are, and this is 36, 6 are. So this is again 0.4. Now multiplying two decimal numbers, it becomes difficult. So what we will do is we will shift this decimal point over here. So what do we get? 4 into 1.4. 4. Correct? We shifted the decimal point over here. So what is the answer? D would be equal to 5.76 kilometers. So the distance between P's starting point and the place is 5.76 kilometers. See, using the formula and just x plus y and x minus y. Later on you won't even need to write all this stuff. You will just write dst over here and we'll just mention x plus y and x minus y, and you will immediately start solving. So boats and streams, at the max you might take 40 to 50 seconds to solve the sums related to boats and streams if you practice. Moving on to question number 4. An ocean current flows at the rate of 1.5 kilometers per hour. A shark can swim in still water at the rate of 4.5 kilometers per hour. What is the average speed for the entire distance traveled if the shark swims from India to Australia and comes back? Now over here, since it is dst, and we will have x plus y as downstream speed, x minus y as upstream speed. So x plus y is nothing but x is 4.5, y is 1.5. So we will have 4.5 plus 1.5, 6, and 4.5 minus 1.5, 3. So 6 kilometers per hour, 3 kilometers per hour, right? Now here we have to find average speed. What is average speed? Speed is nothing but distance upon time. Here we have seen. So average speed is nothing but what we saw, total distance upon total time. Let us find out total distance and total time. The shark starts from India, okay, goes to Australia, okay, and comes back. Do we know the distance between India and Australia? No, we don't even need to know the distance. Let us assume that the distance between India and Australia is d. So the shark travels d kilometers and goes to Australia, again travels d kilometers. First it goes like this, again travels d kilometers and comes back to India. So total distance traveled is nothing but d plus d, okay. This is nothing but total time, okay, 2d upon total time. Now let us find out total time. Now total time is nothing but time to go from India to Australia plus time to go from Australia to India. If we consider India to Australia as say upstream, then Australia to India would be downstream. Exactly opposite you can do, India to Australia as down and Australia to India as up. Vice versa is also true, you will get the same answer, correct? So over here India to Australia is upstream, so time taken to go upstream is say TU, and time taken to go downstream is say TD, right? So what is TU plus TD? That is nothing but the total time taken for the journey, okay. This is nothing but TT, okay. So TT is TU plus TD. What is the formula for time? Time is nothing but distance upon speed. We have seen over here, distance upon speed. So what is the distance traveled upstream? D kilometers. What is the speed for upstream? X minus y. This, that is nothing but 3, plus distance traveled downstream is d kilometers, same. Then speed while traveling downstream is x plus y, that is nothing but 6. That would be what? 6 is the LCM. We will have 2d plus d equal to 3d upon 6. 3 2s are, this is d by 2. So average speed is nothing but total distance is 2d upon total time is d upon 2. This d gets cancelled, 2 gets over here, 4 kilometers per hour. This is the average speed of the shark for the entire distance traveled. See how easily we solved the average speed sum, even if it is not speed, just speed distance time. Even though we had boat and streams, that is we have to consider the ocean current speed and the shark speed, we still found out average speed very easily. Moving on. Question number 5. Ajay takes 4 hours more while swimming upstream than downstream. His speed in still water is 10 kilometers per hour. The speed of the stream is 2 kilometers per hour. What is the distance? Again, it is a speed, distance, time sum, but boats and streams are there. So we will include x plus y for downstream, x minus y for upstream. Value of x is 10, value of y is 2. So x plus y is 10 plus 2, 12, right? And x minus y is 10 minus 2, 8, right? Let's solve the sum. Over here what they have given, find the distance. Now Ajay goes to some place and okay, so this is upstream. Ajay starts from here and goes to some place. Do we know how much distance he traveled? No, that we have to find out. So let us assume that Ajay travels d kilometers, okay. Upstream Ajay goes and again comes downstream, okay, d kilometers while traveling. Distance traveled in both the cases is same, d kilometers. What they given is that Ajay takes 4 hours more while going upstream. So let us assume that Ajay travels while going upstream, Ajay takes TU amount of time. So number of hours needed for Ajay to go upstream is TU, that is nothing but 4 hours more than the time taken to go downstream. So while coming downstream Ajay takes TD, and y upstream time is nothing but 4 hours more than the downstream time, correct? So what is the formula for time? Time is nothing but distance upon speed. So distance traveled upstream is nothing but d kilometers divided by speed is x minus y upstream speed, right? 4 plus what is the downstream distance? It is same, d divided by time is speed for downstream is x plus y. Why? We have seen over here, and the values for x plus y and x minus y are given over here. So d upon 8 would be equal to 4 plus d upon 12. Let us solve this. Okay, what do we get? D upon 8 equal to 12 4s are 48 plus d upon 12, because 12 is the LCM. 4 2s are 4 3s are. So we have 3d equal to 96 plus 2d. D would be equal to 96 kilometers. The distance traveled by Ajay, or the distance traveled from Ajay to that place is 96 kilometers. So Ajay goes 96 kilometers upstream, again comes back 96 kilometers downstream, correct? So this is the answer. Question number 6. Raj swims 26 kilometers downstream in same time as 14 kilometers upstream. What is his speed in still water if speed of the stream is 3 kilometers per hour? Again, d, s, t, and we will have x plus y and x minus y. Okay, so now here they have directly given same time. So time is same, that is time going for upstream is same as time going for downstream. What is the formula for time? Time is distance upon speed. We got it from here. Distance traveled upstream upon speed upstream would be equal to distance traveled downstream upon speed downstream. What is the upstream speed? They have given us 14 kilometers upstream. So 14 divided by what is the speed upstream? X minus y, right? So we will have x minus y. What is the downstream distance? Now here the distance is not same. They have given 26 kilometers downstream. So we will have 26. What is the downstream speed? X plus y. From where? From here, correct? So let's solve this equation. What do we get? We get 14x plus 14y would be equal to 26x minus 26y. Let us solve it in this column. Okay, what do we get? We come over here, that is 40y would be equal to 26 minus 14 is 12x. So x upon y would be equal to 40 upon 12, that is 4 10s are 4 3s are. So 10 upon 3 is x by y. Now what they have given is speed of stream is 3 kilometers. So the value of y is 3 kilometers. So x upon 3 would be equal to 10 upon 3. This gets cancelled. X equal to 10 kilometers per hour. This is the speed of Raj in still water. Going to question number 7. Ratio of Guddi's swimming speed in still water to the speed of river is 7:1. She swims 4.2 kilometers up the river in just 14 minutes. How much time will Guddi take to swim 18.4 kilometers down the river? Again, very easy sum. This is a speed distance time. So dst will have x plus y and x minus y. Okay, value of x they have given, value of x and y they have not given, but what they have given is ratio of Guddi's swimming speed to the speed of river is 7:1. So x upon y is 7 upon 1. So what does that mean? X is nothing but 7 times y, right? So this derivation is important. Let's see how to solve the sum. What they have given over here, she swims 4.2 kilometers up the river in just 14 minutes. So upstream Guddi travels 4.2 kilometers. Time taken is 14 minutes. So what will be the upstream speed? That is nothing but distance upon time. From where did we get that? We get that from our formula. Okay, speed is distance divided by time. So that is nothing but 4.2 divided by 14 minutes. That is 0.3 kilometers per minute. So this is the upstream speed. But we know what is the upstream speed? X minus y. So x minus y is 0.3. Correct? So let's solve it over here. X minus y is 0.3. Value of x is what? 7y. From where did we get? We get it from here, and also x minus y is upstream speed over here. We know that, correct? So 7y minus y is 0.3. 6y is 0.3. Y equal to 0.3 divided by 6. Y equal to 0.05 kilometers per minute. This is the speed of river. Now let us find out the speed of we can find out the speed of Guddi also from here, or we can find it from here. X is nothing but 7 times y. So x is 7 times y, that is 7 into 0.05, that is 0.35 kilometers per minute. Now what we have to find out? The downstream case. In that distance traveled is 18.4 kilometers they have given. Speed is nothing but, we do not know downstream speed, that is nothing but x plus y, that is 0.35 plus 0.05, that is 0.4 kilometers per minute. Correct? This is the speed. So what is the time taken downstream? Nothing but distance upon speed. From here we have distance upon speed. Correct? So that would be 18.4 divided by 0.4, right? So TD is nothing but 184 divided by 4, that is 4 is 16, 24, 46 minutes. So 46 minutes. So the time taken is 46 minutes for Guddi to travel 18.4 kilometers down the river. Moving to question number 8. Find the ratio of swimming speed of Raj in still water to the speed of river if the ratio of time taken to go 10 kilometers upstream and time taken to go 10 kilometers downstream is 11:5. Now over here speed, distance, time, so we have our DST, we will also have our x plus y and x minus y. Now what they have given is that time taken, ratio of time taken to go upstream to ratio of time taken to go downstream is 11:5. So time taken to go upstream, time taken to go downstream, the ratio is 11/5. Correct? Now what they have given is we have to find the ratio of swimming speed of Raj in still water to speed of river. So we do not know x, we do not know y, and we actually have to find the ratio x upon y. This is unknown, that we have to find out. Let us see how to solve it. They have given ratio of time to go upstream and downstream is 11/5. What is time? Time is nothing but distance upon speed. So what do we have over here? Distance upstream divided by speed upstream upon distance downstream divided by speed downstream, that would be 11/5. Now what they say, they have not given exactly how much, have they given the distance over here? Yes, they have given 10 kilometers upstream, 10 kilometers downstream. So we'll have 10 upon, what is the upstream speed? X minus y. What is the downstream distance? 10. Again downstream speed x plus y, that would be 11/5. 10 gets cancelled. What do we get over here? 1 upon x minus y divided by 1 upon x plus y equal to 11/5. So this x plus y will go over here, x minus y will come over here, upon x minus y equal to 11/5. So we have 5x plus 5y equal to 11x minus 11y. So we'll have 5y plus 11y as 16y equal to 11x minus 5y is equal to 6x. Okay, 11 plus 5 is 16. So we'll have x upon y is equal to 16 upon 6, that would be 8/3. So the ratio of swimming speed of Raj in still water to speed of river is 8:3 or 8/3 or 8:3. Going to question number 9. Raj swims for 6.5 hours while going 24 kilometers downstream and 36 kilometers upstream. But he takes 6 hours to swim 36 kilometers downstream and 24 kilometers upstream. At what rate is the river flowing? Now here we have our DST, we will have our x plus y and x minus y. What is x plus y? Downstream speed. What is x minus y? Upstream speed. Correct? Now over here what they have given, Raj swims for 6.5 hours while going 24 km downstream and 36 km upstream. So while going downstream, time is TD. While going upstream, time is TU, and total time taken is 6.5 hours. Now this is mixed fraction. Instead of that, we'll have proper fraction divided by 2. Okay, 13/2 hours. 2 6 are 12 plus 1 13, 13/2 hours. Now time taken is nothing but distance upon speed. We get it from over here. Distance downstream is how much? 24 kilometers upon downstream speed plus what is the upstream distance? 36 kilometers upon upstream speed is equal to 13 by 2. Let's take 2 over here. What do we get? Multiply by 2. 48 is downstream speed plus 36 into 2 is 72 upon upstream speed equal to 13. This is equation number 1. Now this is first case which they have given, right? From the first case we have derived this much. Now they have given a second case also. What is the second case? They say, but he takes 6 hours to swim 36 kilometers downstream and 24 kilometers upstream. So time taken to go downstream plus time taken to go upstream in second case is just 6 hours, correct? So over here, what is the time taken to go downstream? That is nothing but distance upon speed. What is the distance downstream now? It is 36 divided by downstream speed plus 24 kilometers upstream divided by upstream speed, that is 6. This is second equation. Now we have two unknowns, right? ds and us, that is downstream speed and upstream speed, and we have two equations. So let us eliminate one from these two equations. Let us eliminate one unknown or one variable. Now over here we see this is 48, this is 36. Now over here this is 72 and this is 24. 24 into 3 is 72, so we will get these two equal, right? So let's multiply equation number 2 by 3. So what will we get? 36 into 3 is 108 divided by downstream speed plus 24 into 3 is 72 into upstream speed into 6 3s are 18. This is equation number 3. Now 18 is greater than 13. So what we will have? Equation number 3 minus equation number 1. What we will get? 108 downstream speed plus 72 upstream speed minus 48 downstream speed minus 72 upstream speed would be equal to 18 minus 13. So this would get cancelled. We will get 108 minus 48, that would be 60 upon downstream speed would be equal to 18 minus 13 is 5. 5 12s are downstream speed is 12 kilometers per hour. But we know what is downstream speed. It is nothing but x plus y. So x plus y is 12. So keep it like this. Now put the value of downstream speed, that is ds, into equation 1, 2 or 3. Anyone is fine. So let us put it into equation number 1. What do we get? We will solve it over here. We get 48 divided by 12, that is ds, plus 72 divided by us, okay, that is upstream speed, equal to 13. So we get 4 plus 72 divided by upstream speed equal to 13. So we will have 72 upon upstream speed equal to 13 minus 4 is 9. 9 into 8. So upstream speed is equal to nothing but 8 kilometers per hour. But what is upstream speed? We know it is x minus y. So x minus y is nothing but 8 kilometers per hour. So if we add these both equations, okay, if we add, what do we get? Y gets cancelled. X plus x is 2x equal to 8 plus 12 is 20. So what is the value of x? 10 kilometers per hour, right? If the value of x is 10, what will be the value of y? There's space over here, so let's calculate it over here on the right hand side over here, okay? X, value of x is 10, right? We know x minus y equal to 8. We can take any equation. We can take this one also, any equation is fine. X minus y is 8, right? So 10 minus y is 8. So y will be 10 minus 8, that is 2. So speed of the river, or rate at which river is flowing, is 2 kilometers per hour. See how easily, using just dst and x plus y and x minus y, using only these two things, we can solve any sum related to boats and streams. Boats and streams is same or very similar to speed, distance, time. Only thing you have to remember is include the speed of river and include the speed of boat. And there is downstream speed, there is upstream speed. Instead of direct speed, take downstream speed and upstream speed. There is nothing else to this. It is very easy. If you practice, you will be able to solve the sums in hardly 40 seconds. Okay, they are not more than that. You won't even need 1 minute for it. You will hardly need 40 to 45 seconds. So if you like this video, please give it a like and share it with others. You can also leave your comments and suggestions below. Do let us know if you have some topic in your mind, and we will develop a video on it for you. Also, don't forget to subscribe to our channel so that you will remain updated for more such tutorials and videos.